we will talk about multiplying radicals in this video. So when we multiply radicals, we multiply the coefficients together and multiply the radicals together. Then simplify. So remember, we can have square root of a times square root of b, or the mth root of a times the mth root of b. We can say the mth root of a times b. And that's the property we will be using. I will show you a shortcut on our multiplying radicals so that you're not multiplying them and then having to factor. And I'm going to use the break out of jail method to simplify our radicals. So the first one, we have 3 square root 6 times 2 square root 3. And remember, the break out of jail method, if you have outside numbers, they can multiply. If you have inside numbers, they can multiply. You cannot take an outside number and multiply it with the inside number. So we will have 2 times 3. And then inside our radical, we have 6 times 3. Well, 3 times 2 is 6 for the outside. But the inside, we can keep breaking these numbers up so that we have 2 times 3 times 3. Instead of having 18, we can go ahead and break up the factors even further. So we have a group of 3's, and that 3 comes out to the 6, giving us an 18 outside, and the 2 stays in. Negative 2 square root 7 times 5 square root 2. Negative 2 times 5, they're outside, so they combine together, give us negative 10. The inside numbers are 7 times 2, and these are 2 prime numbers, so we can't simplify any further, so they go ahead and multiply together. 7 times 2 is 14. And the more you work on these, the faster you'll get at them, because you'll recognize, oh, 14 can't break down, or 6 is another one that cannot be broken down further or simplified further than just square root 6. 3 square root 3 times 4 square root 8 minus 5 square root 10. And what we are going to do is distribute the 3 square root 3. So we will apply what we did up here to each term. 3 times 4 is 12. And then we have 8 times 3, which I will leave as 8 times 3 instead of 24. And then we'll have negative 5 times 3, which is negative 15. And then we'll have 3 times 10, which will leave us 3 times 10, which is 30. So now we can simplify. The 8 can be broken down into 3 2's. The 2's can be circled. There's a pair of 2's. One of them comes out and meets with the 12. So we'll have 24. 2 times 12 is 24. And then we'll have 3 and 2 left over, which is a 6. Square root 6. And then 3 and 10, if you break up 10, we could get 2 and 5. There's nothing we can pair up with any of those numbers. So we will combine them back together, or take 3 times 10 and it's 30. And again, the more you work on this, you'll say, oh, well, 3 times 10, that's 30. 30 is simplified under the square root. Square root 7 plus square root 2 times square root 7 minus 3 square root 2. Okay, so here we will do the FOIL method. First, outers, inners, lasts. Or what we'll do is take square root of 7. We're going to share it to both of the terms in the second set of parentheses. So 7 times 7 is 49, so square root of 49. We'll evaluate that later. And then we'll have negative 3 square root. 7 times 2, they're both prime. I'm just going to keep that as 14. Or go ahead and multiply that. Then we have 2 times 7 under the square root, so we can combine that into square root 14. And then we have negative 3 square root. 2 times 2 is 4. So essentially we have a 1 in front of the square root. 1 times negative 3 is negative 3, and then 2 times 2 is 4. Well, these are perfect squares, so this will become 7 and 2, which in turn that will be 6. We'll go ahead and add like terms. So essentially there's a 1 in front of that square root 14. And when we combine negative 3 and 1, we get a negative 2 square root 14. This is essentially a 6. So 7 minus 6, which we take the minus from here, 7, negative 6, we get a positive 1. You can leave your answer in that form, or you can place 1 first and then put the negative square root 14 last. As long as you keep the sign in front of the value or your number, keep the sign of the number, and then you can switch them around. Now this one, I've seen many students and people get this one wrong. You cannot distribute that exponent because we are bound by addition. What this means is you'll have to copy and paste 3 plus square root 2 times 3 plus square root 2. Unless you understand the perfect square trinomial, but I'm not going to get into that because it's easier just to copy and paste and go on from there. 3 times 3 is 9, and then we have plus 3 square root 2. Here we have plus 3 square root 2, and we have square root of 4. So with the perfect square trinomial, it's always the square of the first. You always have 2 of the middle. When you multiply these two together, you always have 2 of them. And then with the 4, it's just the squared, the last one squared. Or you just do the FOIL method as I did. So 9, these two can be combined to 6 square root 2. And then we have a 2. 9 plus 2 is 11, plus 6 square root 2, and we are finished. Square root x plus 1 times the quantity square root x minus 3. So FOIL. This is square root x squared, or a little shortcut here. If you notice, as long as we're in square root, if we have the same thing under the square root, we just get what's under the square root. Same thing with the 7 here and the 2's. So you can actually just knock that radical off. So instead of square root of x squared, we could have just shortcutted it and say, oh, that's just x. And then we have negative 3 square root x plus 1 square root x minus 3. Combine like terms. So we have x minus 2 square root x minus 3. And that's it. We are simplifying. Please work on this one by yourself. You may pause the video. Let's look at the answer. So remember, when you have a subtraction or addition and you're trying to square it or whatever, square it, cube it, fourth it, doesn't matter, what you do is you copy this and paste it however many times it says. So I had to paste it twice. I had to copy it and paste it twice. And then square root x times square root x, that just gives us an x, minus 2 square root x, minus 2 square root x plus 4. Add like terms, and we are finished. Okay, the reason why x and square root x are not the same, well, first of all, this one's outside, it doesn't have a radical, where this is a radical, or you can look at it in terms of the powers. So square root of x, that's a half power. Well, half power and one is not the same. Do not write your answer like that unless it is asked. You can keep it in that form. I was just showing that they're not like terms, even if you turn the radical into a power. This concludes this video.